And thank you all for being here, and thank you to ElixirConf for having us today.
Yeah, thank you to our sponsors, and thank you to particularly ElixirConf staff for making everything flow so smoothly, and also our hospitality workers for just taking care of us while we're here.
Absolutely. Let's jump right in.
All right, so here's an overview of how this talk is going to proceed. We will start with introducing ourselves and thank a few people. Then we'll sketch out the problem that we're trying to solve, the solution that we arrived at, a quick demonstration, and then some concluding remarks.
Absolutely. So let's jump into introductions and acknowledgements. So first things first, what is this talk about? So this is a talk about generating OpenAPI specifications from Phoenix controller tests specifically. So warning, yes, this is a talk about tests and documentation. So now is your chance to escape, should you want to.
Well, while people are escaping, Natalie, who are you?
I'm exactly who you said I am. My name is Natalie Perpepaj. I'm a back-end developer at community.com. I've been working in Elixir since 2019. Took a bit of a detour to Ruby, but I've since been back in the world of Elixir for the past year.
Natalie, what's a little known fact about you?
That's a great question. So I used to row in college, and I was a part of a boat that qualified in third place in a race that didn't even participate in. So that was the peak of my athletic career.
That raises further questions that I will save for question and answer time.
That's fair, that's fair. But Geoff, enough about me. Let's hear a little bit about you.
Natalie, you work with me. So I'm Geoff Smith. I'm also a backend developer at community.com. I've been working with Elixir as an amateur since 1.2, and I've been working with Elixir in production since 2017.
So yeah, let's hear a little fun fact about you.
Okay, so a little known fact about me. Not knowing what a chimney sweep is or does, I was so enamored as a child with the film Mary Poppins that the first career ambition I ever expressed was to be a step-in-time guy.
Okay, all right. I think we need to unpack that a little bit later, but for the sake of time, let's move on.
Okay, sure, I get it. Well, we'd love to thank Community. They're the reason for the season, and they gave us great opportunities to work on cool problems like this and some other fascinating scalability issues with communicating with a ton of people.
Okay.
So, wait, what do we do?
Yeah, that's a great question. Community is a platform that helps leaders interact with their audience via SMS. So we focus primarily on enabling the creation of personalized and effective conversations, whether that's one-to-one or on a large scale, in order to drive growth and engagement between a brand and their members.
Awesome. Well, who else should we thank?
Definitely, we want to acknowledge that we're standing on the shoulders of giants here, so that'll become more apparent as we get through this talk. So I wanted to thank all the open source maintainers for Elixir, Plug, Phoenix, and Ecto. This is just a list of people we pulled directly from Hex, so we know that there are definitely many, many more, so thank you all for your contributions. Specifically, we want to thank Eric. So he's had a hand in each of these, and he also works with us at Community. And Eric is a great resource, super helpful, super supportive. So special thanks to Eric, 10 out of 10, would recommend working with Eric.
We're big Eric boosters.
Yeah, who else should we thank?
Oh, probably our collaborators. They are pretty cool folks. So huge credit to Geoff Matthias, who is sitting in the second row, but he had the initial idea for this and was the center of this effort. He'd been thinking about the problem of how you elevate unit tests into more shareable documentation for several years before even embarking on this project with Adi, the two of whom spiked on the problem and figured out what works, what doesn't, so that when we had the opportunity to work on this project in a hackathon, we could hit the ground running just as soon as that opportunity presented itself. Adi was also instrumental in the metaprogramming element that we will cover later, but it enables the solution to be really lightweight and integrate with things with very minimal code. Real magician, real pro, 10 out of 10, would love to work with Adi. And last but not least, I would love to shout out Brian, who was a close collaborator with us throughout the hackathon. We love Brian.
Yeah, definitely love Brian.
All right, so what's our problem space look like? So I was really surprised to learn that this figure was so low, but 80% of companies fail to maintain their documentation in a given year. Where does this stat come from? We just don't know. I made this up. We couldn't find it documented anywhere, and it's our so it's our best guess without looking very hard or changing a template that I thought was cool. But the problem remains. So how do we document an existing large API for other parts of our organization? We got client developers just running all of our front-end apps. We got product folks. We got sales engineers, and probably many more. So how do we keep that up to date as it grows and changes with 10, 20, 40 back-end maintainers? And how do we make sure that we don't accidentally deprecate an endpoint or break a contract with our front-end clients? So the secret to that is probably centralization, but there is another problem. Tests and documentation often live separately from an application and even separately from one another. So there's a huge risk of drift between those things if you're not diligent and careful. So what were we doing at Community? So for a while we used Apiary, which is a fantastic tool. It's a gigantic JSON structure that you can just log in and edit. And it does a great job if you can stay disciplined and update it yourself. So we have like a company-wide mutex where somebody gets to change it. And it was part of our acceptance criteria for a given story, so the work wasn't done until it was documented. This worked pretty well, but some of our front-end developers really wanted to move over to Postman because it had some more features and it really helped some of our less technical aspects of our team flourish. However, we didn't have a great rollout plan for migrating between the two, so there were a few months of just things didn't really get documented. And we found ourselves in a position where we had a lot of endpoints that were moving and changing, and we don't really have them. So.
Yes. So what are we missing? Why is there so much friction when it comes to documentation?
Oh boy. Okay. So as we stated before, these things exist separately, and you got your service in one place and your docs in another place. That's a little tough. It does require discipline, as we said before, and while the problem is potentially the tool, it certainly is only as good as we are. So if we're not using it, it's not going to do anything for us. So on top of that, there's going to be some things that you just can never dodge. They're always going to come at you. So your team's going to want to change tools at times. Things go out of date. You might have good reasons for switching. You might not. So that's one aspect. Sometimes just the business won't allow for these kinds of things. So you might have to build a working prototype really quickly, and it has to be validated by actual users before we're going to put any more time into it. Startups move fast, they're ever mercurial, they're never hygienic, and their priorities are always changing. So, some days you get to have a thing in a good working state, and nobody really wants you to go back and work on it. And even if you can make a case for getting back to it, you might not get to just really have your say and have your way. So, what's at another standard? Is it even the right choice? I don't know. So we've got a mature code base, and the sort of the golden path for OpenAPI is to write a specification first, and then your endpoints after. Okay. Well, let's not be too quick to dismiss this. We've got a standard, let's add it. So what does it have going for it? Here are some selling points. So I'm a little harsh on new things, but OpenAPI has a lot going for it. So it's language agnostic. It plugs in with a lot of different tools. It can be reviewed by non-technical contributors, partly because it's represented as JSON or YAML. So its hierarchical nature makes it really easy to see what goes where, and it's human editable. Let's see, what else? There's a lot of code gen features, so you can write front-end clients based off of these contracts. You can write back-end clients based off of these contracts, which wasn't our problem, but you could do it. So it's got a lot of cool features, plugs in with Postman, which we were already using. Some of our front-end devs really love Pact, so that's probably cool. And yeah, so it's ideal for just laying out an API. So what does that look like? So this is a pretty minimal specification. This is cribbed from the OpenAPI docs themselves. They give you a little pet shop. It's a basic CRUD app. And we pared it down to fit into a slide, maybe. I hope you can read it. So this is just the get endpoint where if you have the ID of your chosen pet, you can get it. You might get back a nice little doggy. If you have the wrong ID, well, 404, your doggy's in another shop. Good luck. But these are the rules, and it lays it out pretty succinctly. Yeah, I think that's all there is to say about that. So let's circle back. It's neat, it's flexible, it's pretty compelling. What does it do for our friction? It doesn't address the problem here, the problem. So let's not dwell too long on our own shortcomings. OpenAPI is still a really good representation for APIs. It's ubiquitous, it's well supported. It can be versioned as your application changes. Maybe we can glean something out of it. So we need a spec, probably.
All right, but how do we get that? Do we have any raw material lying around that we can use?
Yeah, where do we find this information? If only we knew. Well, we've got these laying around. While we really had partially maintained our documentation for our endpoints, we had been especially diligent to unit test our entire suite of services, including Phoenix controller tests. Oftentimes, these tests served as our only source of documentation, not including perhaps our router or digging through source code, but that can sometimes get messy as things evolve organically. Some people have even argued that tests themselves are documentation, big if true. That's kind of the whole ball game here. Okay, so we need a test. Here's one that has been generated by Phoenix generators, and it's pretty bare bones, but it confirms certain responses. It's really just like a great way to orient yourself, pretty good place to depart from. There's no way that these generators could possibly know all of the ways that your application should behave, so it's good to bolster these kinds of things or use them as a basis for writing more enhanced tests. And on top of that, it's really good practice to have test coverage for all of the way that your controllers can interact with your users. So let's say you've got your happy path and you've got your sad path where it's not found, you've got your sad path for authentication. There are a lot of ways that it can go, and you should probably nail that down with a test per case. Oh, look at all those green dots. We love it. We love it. So this allows us to shift the problem from maintaining something that we haven't really prioritized, for docs, to really taking advantage of something that we have in droves, which are our tests, and we maintain those. So as we saw in that test before, there's a key piece of information that every controller test really relies on, and that is the plug.con. So what is in there? It's everything here on this bullet list. We got paths, we got params, we got everything you want. We really want to dial in on that response con because it carries pretty much all of our request information and more, the response. So that's pretty nice. That's got a good thing going for it. What's in the API spec? All right, let's go back. It's almost like they're describing a common protocol.
Kind of, right? All right, so we acknowledge that we have the information on the con, and we need to generate an OpenAPI specification. Sorry, there's a fly.
That's big.
Yeah, big. Let's hope not. So how do we get there? What's going to help us accomplish that? So enter connect the docs. Connect the docs is a proof of concept library that allows the generation of OpenAPI specifications from unit tests without adding much overhead when introduced to a large code base. So it won't meaningfully affect the time spent running tests either, which is super important. It was completed in a recent hackathon at our company. There had definitely been many attempts made at the company before, but with the solid week of uninterrupted time and multiple contributors, this allowed the idea to fully crystallize. All right, so how does that work? So at a high level, with some meta-programming magic, we can override the HTTP method functions provided by the Phoenix contest to intercept the con and harvest endpoint information for building out a specification. So this, combined with a gen server equipped with a single function for accumulating the con information into an OpenAPI spec, we can generate a full specification. So what does that overrider look like? So this is a snippet from Connect the Dots. This is our contest overrider module. So as you can see here, we're overriding the HTTP methods so that when called, we can access the response con for data collection. The con gets dispatched as expected, but then we forward the response con to our collector server so that data can be added to state. So that's the new line of code. That's the important stuff right there. The reason we had opted for a gen server was we needed to maintain state and also handle asynchronous messaging. The response con is then returned unaffected to your tests. We're not doing any kind of changes to the con at all. Well, yeah, Elixir. So definitely want to shout out Adi here. This was plucked directly from an earlier iteration of the work that was done at Community, and we use this as our jumping off point. So he really is, as Geoff said, a magician. All right, cool. So we have our con. That's great. What was our strategy in actually digesting the data and turning it into a specification? So we used the strategy of for decomposing the construct into a specification was to create a separate module, a single responsibility module, for each aspect of the specification. So these modules would expose a single function that would accept the con and return the part it was responsible for. So we ended up with things like HTTP actions, path parameters, securities, types, and more. These would build out a map-based representation of the OpenAPI spec, which would then reduce into a single gigantic map that could be serialized into JSON. So we wrote these purpose-built modules for serializing the information, and then the gen server for collecting the information and reducing it into a specification. So with this pattern, each test could fire off an asynchronous message containing a con with little overhead to the test suite. So these are large applications. Definitely wanted to make sure we weren't adding or conflating any information with the business logic there. So we actually also use the XUnit after suite callback to let us know to wrap things up and then persist that spec.
But Natalie, I don't know what is in an OpenAPI spec. How do they look? What are the parts? That's a great
question. That's a great, great question. Let me tell you about it. So on the left, we have an example of a portion of the path body for a specification for the HTTP action portion of a specification. So this is just a very small portion. And on the right, we have the map output from the module corresponding to that part of the spec. So if we continue this approach for each portion of a spec, we end up with modules for path params, responses, types, security, and more. At a top level module then consolidates each of parts of the map and reduces it down to a single large map to be turned into a specification. So as you can see, this pet example is just for one endpoint, and it's fairly large. So focusing on specific portions of a specification can make it easier to reason about. It also allows us to unit test our modules and isolate potential errors.
All right, so we need to provide some sort of demonstration API to run this against, right? And we can't really use our production code in front of all of you. So we've decided to whip up a quick contrivance to appeal to the mountain pastime of rock hounding. So this is a pretty common hobby in Colorado where people just go out into the field for rock and mineral formations, and they'll just scout them out. Sometimes they'll take them home, sometimes it's a catch and release sort of a thing. But everyone can do it in their own way. It's just out in the natural world. We love this wholesome tradition and think that it is ripe time to disrupt and monetize this otherwise non-commercial hobby. The plan? Crowdsource geology. So if you've got a rock, we want to hear about it, and we're going to have the biggest, most data. Is it good? We don't know. But we're going to democratize this hobby. Everyday citizen scientists can share what they find in the field. Whether they're looking for mussels or I don't know. These are great rocks. We've never encountered data that we didn't like, and we're not about to leave rocks on the table. It also seems silly to hound in the mountains alone. Surely we can extend this hobby to South Africa, Alcatraz, Fast 5 premieres, and the island continent of Alaska. So I don't recall learning about any of these rocks in my geology class in university, and so maybe they'll be interested in it. I don't know. We'll deal with that later.
Well, this is definitely an app I can get behind. I mean, I have all of these healing crystals, which those are rocks, right? Whatever.
knows?
And I really want to share them with the world. But I don't know how to use this API at all. There's no documentation, but there are tests.
There are tasks.
So while Geoff goes ahead and sets up,
Did the
he's
screen
going
do
to
the
drive,
thing? Will
I'm
the
gonna
screen do the
navigate.
thing?
and we're going to get there.
It's going. It's going.
Yes.
Yay!
So first things first, this is an application that's a perfect candidate for Connect the Docs. We want to bring and connect the docs in. So we're going to add Connect the Docs to our mixed steps and specify the test environment only. We're getting there. Isn't he quick? Look at him go.
It's pretty slow. It's pretty agonizing.
Oh.
Oh no! Thanks,
All right.
everyone. Oh no! It moved. Okay, I see
All right,
what happens.
so yeah, while he's doing that,
Oh.
I'm just going to preempt the next part. So now that we have Connect the Docs in our application, we're going to want to actually use that new contest that we overrode. So we're adding that to the con case in our application. Bingo, bango, you got it. All right, last but not least, we need to actually start Connect the Docs. So in our test helper, we're going to go ahead and start it. And that's it. That is it, folks. 3 lines of code, no changes to your controller test suite at all. So how do we actually run this? How do we start it up? So we use a environment variable flag, connect the docs recording set to on, and run our tests. Let's see what that does.
If I got any typos, I'm blaming all my pairs here. Hey,
All
we ran
right.
some tests.
So that actually generated an OpenAPI spec JSON file that was stored to the root directory. We also provide an environment variable should you want to specify a different directory, but that's currently the default, which is the root. So now we have our JSON. What are we going to do with it?
Let's paste it in the Swagger editor and see what we get.
Woo.
Hey, we got an API, folks.
Docs
Oh,
on
maybe
deck.
not that. Well, let's not dwell on that.
Awesome. Quick switch back. See how well this behaves.
It's a good mountain pun. So we have a spec and maybe a slide. Give it a second.
Maybe slides? Slides? Oh. We're back to where we started. No, where am I going? Dun, dun, dun.
Does it need to get dragged over, perhaps?
It potentially does. Where is it? One moment, folks.
So I'd love to hear from the audience favorite rocks. You, sir, in the conference badge. I heard marbles. You, sir, in the conference badge. Favorite rock. Topaz. That sounds like a rock. Hey, we got slides. All right.
Ah,
Do we have speaker notes?
no.
All right, so we have a spec.
We're doing it live.
What are we going to do with that? Well, it's documentation. Share it with everyone. But on top of that, you could put it in version control, and further, you could monitor that for changes, perhaps in CI. And on top of that, you could, monitor in CI further, not just committing it, but diffing changes to see if any endpoints break. And oh boy, how do we advance slides now?
Can we? I think we have to switch. All right.
Well, what did we learn today?
That's a great question. Well, don't switch laptops.
That is what we learned.
That's what we learned. But also, we ran into some gotchas when building this library. Gotchas.
Hey,
Yeah,
all right.
first things first. Multiple tests exist for a given path. And you're testing both the happy paths, the sad paths, and those will have different status codes, different response bodies, things of that nature that you want to make sure you're not overriding when you're creating your specification. So that was definitely important. In a similar vein, not all parts of the application are authenticated the same way. So how are we going to capture accurately the strategies we use for each of our endpoints without overriding any information? Next up, type translation. So we were dealing with different types, including nested types, and mapping that from a regular map to what it needs to be in JSON was something we had to wrap our heads around for a minute, but we got there. And last but not least, there are different ways to write a valid spec. We are not generating source code. That wasn't our use case for this tool. Our use case was generating complete human-readable documentation. So we went with keeping everything local to the action as opposed to generating some global schemas that were then referenced throughout the spec. All right, we definitely acknowledge that there's some future work that needs to be done. For example, pluggable parsers would be a great use case for things like required parameters. So there are many ways that you can specify required parameters, whether that's using change set, and it's basically impossible to automate all the ways in which an application can specify required params. And then next up, dynamic descriptions. So right now, all the descriptions are static and generated once, but in order to make a robust specification, having those dynamic descriptions, dynamic examples, something that you could have ownership over, would make those documentations a lot more useful to other users. All right, diffing changes. So right now, every time you run a test run, you can have different output on your specification. So changing this to be deterministic and sorting it by endpoints can help diff and identify easily the changes that were made, whether those were intentional or a side effect of something. You could have microservices where information exists in different places, and how do we unify that and consolidate that in a way that makes sense and is appropriate? And last but not least, API gateways exist, so your endpoints could be remapped using the API gateway. How does that get represented in a spec?
What else did we learn?
I think this might be potentially the biggest takeaway from today's talk, so lessons for your organization. First things first, if you're thinking about migrating your tool or your documentation, take a pause, identify, is it a problem with the tool or is it a problem with the process behind it? If it's a problem with the process, try to come up with a different action plan. If it is a problem with the tool, that's all right. If you choose to migrate, come up with a strategy and stick to it. It's a lot easier to migrate documentation that exists than to write it from scratch. All right, work isn't done until it's documented. This is definitely a nice standard to set for a growing application. So that's why you do retros for sprints. That's why you have postmortems after incidents. So a team that has access to the information that it already knows can anticipate, preempt, and prevent anything down the line.
Yeah, something like agility.
Yeah. And last but not least, hackathons are enablers. So that this actually gives us the opportunity to identify a problem that the organization didn't know it had. And without that heads down time, we wouldn't have this talk, and we wouldn't have a potential solution to our problem. Yeah.
Will it? Thank you, photographers, and thank you for your time.